Some opinions save careers, some opinions save reputations, and some opinions, the ones that get ignored, dismissed, laughed at, save lives. Captain Nolan Price doesn't believe in opinions. Not from passengers, not from junior officers, and certainly not from flight attendants. He believes in numbers, his numbers, the calculations he runs in his head, the shortcuts he's perfected over 16 years, the mental math that's faster than any computer. Today on Flight 562 from Toronto to Lisbon, he's about to dismiss the one opinion that matters more than anything he's ever calculated. Because the flight attendant who just told him she smells jet fuel in the cabin? She's not guessing. She spent 6 years designing the fuel systems for Boeing. She knows what Jet A smells like the way a sommelier knows Bordeaux. And right now, at 38,000 feet over the North Atlantic, her opinion is the only thing standing between 190 passengers and an ocean they'll never swim out of. It's 6:22 p.m., Toronto Pearson International Airport, Terminal 1, Gate D32. The Boeing 787 Dreamliner sits at the gate in the golden light of a Canadian autumn evening, its composite fuselage gleaming under the terminal floods. The aircraft is beautiful, sleek, modern, the pride of the fleet. Registration CGHPX, 3 years old, 12,000 flight hours, maintained on schedule, inspected on schedule, fueled on schedule. Everything about this aircraft says reliable. Everything about this aircraft says safe. Ground crew completes the final walkthrough. Baggage handlers load the last containers. The fuel truck disconnects and pulls away, leaving the aircraft with what the paperwork says is 47,200 kilograms of Jet A fuel, enough for the 7-hour transatlantic crossing to Lisbon with standard reserves. The paperwork says 47,200. The actual amount in the tanks is different, but nobody knows that yet. Inside the terminal, 190 passengers gather at the gate. Business travelers heading to European meetings, a Portuguese family returning home after visiting relatives in Ontario, a group of Canadian university students on a semester abroad program, an elderly couple celebrating their 50th anniversary with a trip to the Algarve coast. 190 lives, each one carrying plans, expectations, and the assumption that the people flying this aircraft know what they're doing. Captain Nolan Price arrives at the gate 15 minutes before boarding begins. 44 years old, 16 years in commercial aviation with a spotless safety record that he mentions often in briefings, in conversations with management, in casual remarks to junior crew that aren't as casual as they seem. Price is lean, sharp-featured, with dark hair cut military short, and green eyes that move constantly, assessing everything and everyone like variables in an equation. He wears his uniform like a second skin, 4 gold stripes perfectly aligned, shirt pressed to razor creases, shoes polished to a mirror finish. His watch is a Rolex Submariner, not because he cares about luxury, but because he cares about precision. Everything about Nolan Price is about precision, or at least his version of precision. Price's arrogance isn't the loud, explosive kind. It's quieter, more dangerous. He doesn't scream at people or make scenes. He dismisses them calmly, efficiently, the way you dismiss a calculation error. Acknowledge it exists, explain why it's wrong, move on. He's the kind of captain who genuinely believes he's the smartest person in any room he enters. And the frustrating thing is that he's often close to right. His technical knowledge is extensive. His flying skills are sharp. He can calculate crosswind components, fuel burns, and descent profiles in his head faster than most pilots can punch them into the flight computer. That's his gift. That's also his fatal flaw, because Nolan Price trusts his mental math more than he trusts the instruments, more than he trusts the computers, and far more than he trusts the people around him. He takes shortcuts, not reckless ones, not obvious ones, but small, consistent shortcuts that shave margins thinner than they should be. Fuel calculations rounded down instead of up. Reserve margins trimmed by 2% here, 3% there. Weather deviations calculated in his head instead of verified with dispatch. 16 years of shortcuts, and nothing has ever gone wrong, which to a man like Price is proof that the shortcuts work. He's never considered the alternative explanation, that he's been lucky, and luck, unlike skill, runs out. Rebecca Thorne boards the aircraft 40 minutes before the passengers, 36 years old, 4 years as a flight attendant. But before the uniform, before the safety demonstrations and the beverage service, Rebecca Thorne was an aerospace engineer, not just any engineer, a fuel system specialist at Boeing's facility in Everett, Washington. 6 years on the 787 program specifically. She worked on the very aircraft type she's now serving coffee on. She knows every pipe, every valve, every sensor, every pump in the 787's fuel system. She can tell you the pressure differential in the center tank at cruise altitude. She can explain the cross-feed logic between the left and right wing tanks. She can identify Jet A fuel by smell alone, that distinctive kerosene petroleum odor that most people wouldn't recognize, but that she's been around so often it's burned into her memory permanently. She left Boeing because the corporate restructuring after a series of quality scandals made the workplace unbearable. Teams gutted, budgets slashed. The engineers who cared about getting things right were replaced by managers who cared about getting things done fast. Rebecca watched safety margins erode from the inside and decided she'd rather serve passengers than watch an engineering culture she loved destroy itself. Flying gave her a new perspective. Literally, she still loves aviation, still reads maintenance logs for fun, still notices things on aircraft that no flight attendant should notice because no flight attendant has the training to notice them. The slight vibration in a flap motor that signals early bearing wear, the discoloration on a wing root that could indicate stress fatigue, the smell of hydraulic fluid that means a seal is degrading somewhere behind a panel. She keeps these observations to herself mostly. Files, quiet reports, mentions things to maintenance crews who usually look at her with a mixture of confusion and respect. Today, her training is about to matter more than it ever has. Rebecca walks through the cabin completing her pre-flight checks, overhead bins secured, emergency exits clear, safety equipment in place. She moves through the economy section, then up to business class, then back toward the aft galley. Everything looks normal. Everything smells normal. The aircraft has that standard new plane scent, recycled air mixed with cleaning products and the faint industrial smell of composite materials. Nothing unusual, nothing concerning. She finishes her checks and heads to the forward galley for the crew briefing. The briefing is short. Price runs it like a corporate presentation, efficient, clipped, no room for questions. He introduces himself and First Officer Amanda Chen, a 33-year-old with 7 years of experience, and the careful demeanor of someone who's learned to pick her battles. Price outlines the flight plan, 7 hours and 10 minutes, cruising at 38,000 feet, standard North Atlantic track, weather clear over the ocean with possible headwinds increasing fuel burn by approximately 2%. He mentions the fuel load, 47,200 kilos, which he calls more than adequate. He doesn't mention reserves specifically. He doesn't invite input from the cabin crew. He tells them to prepare for an on-time departure and to keep the cockpit interruptions to a minimum. His exact words: "If it's not an emergency, handle it yourselves. I don't need updates on turbulence complaints or seat assignment disputes." He says this looking directly at Rebecca, though she hasn't said a word. Something about her, the way she holds eye contact, the way she stands like someone who's used to being in rooms where decisions are made, seems to irritate him. He finishes the briefing, turns, walks to the cockpit. Rebecca watches him go and feels something she can't quite name. Not anger, not fear, something closer to recognition. She's met this type before. In engineering meetings at Boeing, there was always one, the senior engineer who dismissed every concern because he'd been doing this longer, because his calculations were better, because admitting uncertainty was weakness. She knows how this type operates. She knows how they fail. Boarding completes without incident. 190 passengers settle into their seats. Seatbelts click. Phones switch to airplane mode. The safety demonstration plays on the overhead screens while Rebecca and her team walk the aisles checking compliance. The forward door closes. The jet bridge retracts. The 787 pushes back from Gate D32 at 7:08 p.m., 11 minutes behind schedule because of a late connecting passenger. Price doesn't like being late. He mentions it twice on the cockpit intercom, as if the cabin crew personally delayed the flight. The takeoff is smooth. The 787 lifts off runway 24R and climbs into the darkening Canadian sky. banking east over Lake Ontario before settling onto its transatlantic heading. Below, the lights of Toronto spread out like a circuit board. Above, the first stars of the evening appear. Inside the cabin, passengers relax, movies start, headphones go on, the first beverage service begins. Everything feels normal, safe, routine. But in the belly of the aircraft, hidden behind composite panels and insulation, something is wrong. A fuel line connection in the center tank, a coupling joint that was serviced during the aircraft's last maintenance check 3 days ago, isn't sealed properly. The torque specification was met on paper, but the gasket inside the coupling is defective. Microscopic cracks in the rubber that no visual inspection would catch. At ground level, with fuel at ambient pressure, the cracks hold. But at 38,000 feet, with the pressure differential between the pressurized fuel system and the ambient cabin environment, those microscopic cracks are going to open. And when they do, Jet A fuel is going to seep through the coupling, past the thermal insulation and into the air circulation system. Slowly at first, then faster, and someone on this aircraft is going to smell it. The question is whether the person in command will listen. 2 hours and 40 minutes into the flight, the 787 is at 38,000 feet midway across the North Atlantic. Below, there's nothing but black ocean stretching in every direction. No cities, no coastlines, no runways. The nearest diversion airport is Keflavik, Iceland, roughly 90 minutes to the north. The next option is Santa Maria in the Azores, 2 hours to the southeast. Out here over the Atlantic, problems don't have convenient solutions. Problems have consequences. The meal service is wrapping up. Trays collected, galleys tidied, cabin lights dimming for the overnight phase of the flight. Most passengers are settling in, blankets pulled up, eye masks on, the cabin entering that quiet hum of a long-haul crossing. Rebecca is in the aft galley organizing service equipment when she notices it. Not dramatically, not suddenly. It comes gradually, a faint chemical odor in the recirculated air, something sharp underneath the normal cabin smells, something that shouldn't be there. She stops what she's doing, inhales slowly through her nose. There it is again, faint but unmistakable to someone who spent 6 years working around it every single day. Jet A fuel, kerosene-based, that distinctive petroleum signature that commercial aviation runs on. She knows this smell the way a chef knows burning garlic. Instantly, instinctively, without a moment of doubt. Rebecca doesn't panic, she doesn't alert passengers. She walks calmly through the aft cabin, breathing carefully, tracking the smell. It's strongest near the aft galley floor, near where the air circulation ducts run beneath the cabin panels. She crouches down. The smell is definitely coming from below, from the air system, which means it's not a spill. It's not a passenger's perfume. It's fuel vapor entering the cabin through the environmental control system. And that means there's a leak somewhere in the fuel system that's allowing Jet A to reach the air circulation architecture. In a 787, with its composite fuselage and electrical systems, fuel vapor in the wrong place isn't just uncomfortable, it's potentially catastrophic. She heads to the cockpit, knocks on the door. Price opens it with the expression of a man who's been interrupted during something important, which, in his mind, is always. Rebecca tells him she's detecting a fuel odor in the aft cabin, specifically near the galley floor vents. She describes it precisely: kerosene petroleum signature, consistent with Jet A. Concentration increasing over the past 10 minutes. Source appears to be the environmental control system ducting. She speaks like an engineer because she is one. Price looks at her for 3 seconds. His face doesn't change. Then he responds, his exact words: "Serve coffee, not opinions. Leave the flying to pilots." He tells her that fuel odor on the 787 is normal during certain flight phases. Something about pressure equalization in the fuel tanks, he says, waving his hand as if swatting away a fly. He tells her to go back to the cabin and stop alarming the crew. He turns back to his instruments. Conversation over. Rebecca stands at the cockpit door for a moment. She could leave. She could accept the captain's authority, go back to the galley, and hope he's right. But she can't, because she knows he's wrong. Pressure equalization doesn't produce detectable fuel odor in the cabin on a 787. The system is specifically designed to prevent that. She helped design it. She knows every ventilation pathway, every isolation valve, every fail-safe in that system. If fuel smell is reaching the cabin, something is broken, something is leaking, and every minute that passes, it's getting worse. She returns to the galley, but she doesn't stop. She picks up the interphone and calls First Officer Amanda Chen directly. Chen answers from the cockpit. Price is in the lavatory, a brief window of privacy. Rebecca speaks quickly and precisely. She identifies herself, then explains what she's smelling. But this time, she adds context that no ordinary flight attendant would have. She explains that she spent 6 years as a fuel systems engineer on the 787 program at Boeing. She describes the specific ducting pathways where fuel vapor could enter the cabin environmental system. She identifies the most likely failure point, a coupling joint in the center tank feed system that, if improperly sealed, could allow fuel seepage under cruise pressure differential. She tells Chen to check the fuel quantity indicators on both wing tanks and the center tank. If there's a leak, the numbers won't match the flight plan burn rate. The fuel consumption will be higher than calculated. Chen listens in silence. Then she checks the numbers, and the color drains from her face. The flight plan calls for a fuel burn of approximately 5,400 kilograms per hour at current weight and altitude. 3 hours into the flight, they should have burned roughly 16,200 kilos, leaving about 31,000 kilos in the tanks. The fuel quantity indicator reads 28,800 kilos. They're 2,200 kilograms short, over 2 metric tons of fuel that the engines didn't burn, but that isn't in the tanks anymore, it's somewhere else. Leaking, seeping, evaporating into spaces where fuel should never be. Chen doesn't wait for Price to return from the lavatory. She pulls up the fuel system synoptic page on the center display. The center tank quantity is dropping at a rate that doesn't match the engine feed demand. The left and right wing tanks are normal. The center tank is bleeding. Something between the center tank and the wing feed manifold is compromised. She's looking at an active fuel leak at 38,000 feet over the North Atlantic. Price returns to the cockpit. Chen tells him what she's found, shows him the numbers, the fuel discrepancy, the center tank bleed rate, the flight attendant's report. Price looks at the data, and his first reaction is denial. He tells Chen, the fuel gauges on the 787 have known accuracy issues at certain temperatures. He tells her the discrepancy is within normal variation. He runs his own mental calculation, his famous mental math, and concludes that they have enough fuel to reach Lisbon with adequate reserves. He tells Chen to continue on course, no diversion, no fuel dump, no emergency, but the numbers don't lie, and they're getting worse. What Price doesn't realize, what his mental math can't account for, is that the leak rate is accelerating. The defective gasket, which started with microscopic cracks, is now degrading under the constant pressure differential. What was a slow seep an hour ago is now a steady flow. Fuel vapor concentration in the aft section of the aircraft is increasing. Rebecca can smell it clearly now, not just near the floor vents, but at standing height. Some passengers in the aft rows are starting to notice. A man in 38C wrinkles his nose. A woman in 41A asks her seatmate if she smells something chemical. A teenager in 36D pulls his shirt collar over his nose. Rebecca calls the cockpit again. This time, Price answers. She reports that the fuel odor is now detectable at passenger level in rows 35 through 42 and is intensifying. She requests an immediate assessment of the fuel system status. Price's response is colder this time. He tells her he's already evaluated the situation. He tells her the cabin crew's job is passenger comfort, not aircraft systems analysis. He tells her that if she calls the cockpit one more time with her opinions about fuel systems, he'll write her up for interfering with flight operations. Then he hangs up. Rebecca stands in the galley holding the interphone. She has a choice. Accept the captain's authority and hope he's right, or trust her own training, her 6 years of engineering expertise on this exact aircraft type, and take action. She chooses her training. She calls Chen again. Price is right there this time, but Chen answers the interphone from her side panel before Price can object. Rebecca tells Chen one thing. Check the center tank quantity right now. Compare it to 2 minutes ago. Chen looks. The center tank has dropped another 180 kilograms in 3 minutes. That's not gauge error. That's not temperature variation. That's a leak rate of 3,600 kilograms per hour. At that rate, they'll lose their center tank fuel completely within 90 minutes, and their total remaining fuel, factoring the leak, won't be enough to reach Lisbon. Chen turns to Price, shows him the numbers again. This time, the math is undeniable. Even Price's mental calculations can't make these numbers work. The center tank is hemorrhaging fuel. Their reserves are evaporating, literally. If they continue to Lisbon, they risk running critically low on fuel over the eastern Atlantic with no diversion options. If they divert now or to Keflavik, Iceland, 90 minutes north, they can make it safely with margin to spare. Price stares at the instruments. His jaw is tight. His hands grip the yoke. For 16 years, he's never diverted a flight. Never. It's a point of pride. A record he mentions in every annual review, and now a flight attendant, a woman he told to serve coffee, is the reason that record is about to end. He sits in silence for 30 seconds that feel like 30 minutes. Chen watches him. Rebecca listens on the interphone from the galley. 190 passengers sleep and watch movies, unaware that the fuel keeping them airborne is leaking into the structure of the aircraft beneath their feet. And then Chen speaks, quietly, firmly. She tells Price she's declaring a fuel emergency and initiating divert procedures to Keflavik. She's not asking. Her hand moves to the radio. Price doesn't fight it. He can't. The numbers are on the screen in front of him, undeniable and getting worse by the minute. The center tank is losing fuel at an accelerating rate, and his mental math, the math he's trusted more than any instrument for 16 years, can't make the Lisbon routing work anymore. He nods once, a single tight nod. And just like that, his 16-year perfect record of 0 diversions dies at 38,000 feet over the North Atlantic. Chen takes the radio. She contacts Shanwick Oceanic Control and declares Pan-Pan, an urgency call, one step below a full mayday. She reports a suspected fuel system leak with decreasing center tank quantity and requests an immediate rerouting to Keflavik International Airport, Iceland. The controller responds within seconds. Clear direct Keflavik. Descent at pilot's discretion. Emergency services on standby. The machine of aviation safety begins to move. Controllers clearing airspace, airport fire crews rolling to positions, medical teams preparing. All because a flight attendant smelled something wrong and refused to stop saying so. The 787 banks left and begins its descent toward Iceland. Rebecca, still in the aft galley, feels the aircraft turn and allows herself one moment, just one, of relief. Not satisfaction, not vindication, relief. Because she knows what was at stake. She knows the mathematics of fuel exhaustion over open ocean. She knows that if this aircraft had continued to Lisbon somewhere over the eastern Atlantic, the engines would have begun to starve. And a 787 with empty tanks over open water at night, with 190 passengers aboard, is not a problem anyone solves. In the cabin, passengers wake up and feel the descent. Some check the flight map on their screens and see the aircraft turning north, away from the planned route. Murmurs spread. Flight attendants move through the aisles, answering questions with practiced calm. There's a minor technical issue requiring a precautionary landing in Iceland. Nothing to be concerned about. The airline will arrange onward travel. It's the truth, stripped of the terrifying details. Rebecca helps her team. She's calm. She's professional. She doesn't mention what she knows. She doesn't mention what she smells. She does her job. In the cockpit, Chen monitors the fuel state continuously. The center tank continues to bleed. The rate has increased to over 4,000 kilograms per hour now. At this rate, they're losing fuel faster than the right engine is burning it. She calculates and recalculates. The wing tanks are holding steady. The leak is isolated to the center tank system, as long as the wing tanks remain intact. They have enough fuel to reach Keflavik, but the margin is thinner than she'd like. Much thinner. Price sits in the left seat and says almost nothing. He flies the approach with mechanical precision. His stick and rudder skills are excellent. They always have been. Whatever else is true about Nolan Price, the man can fly an airplane. But flying an airplane and commanding one are different things, and tonight, the difference is painfully clear. 47 minutes after the diversion decision, Keflavik comes into view. The runway lights cut through the Icelandic darkness like a luminous pathway across the volcanic landscape. Wind is gusting at 25 knots from the northwest. Not ideal, but manageable. Chen runs the fuel numbers one final time. They'll land with approximately 14,200 kilograms, well above minimum, but nearly 6,000 kilos less than what the flight plan projected for this point in the journey. 6,000 kilograms of fuel that leaked out of a defective coupling and into the structure of the aircraft. The number is sobering. The landing is smooth. Price puts the 787 on runway 20 with the kind of textbook touchdown that comes from 16 years of practice. The aircraft decelerates, exits the runway, and taxis toward the terminal where emergency vehicles are waiting. 2 fire trucks, an ambulance, and a fuel spill response team. The engines shut down, the aircraft stops, and for a moment, everything is quiet. Then the investigation begins. The fuel spill team approaches the aircraft with detection equipment. Within minutes, they confirm what Rebecca diagnosed from the cabin with nothing but her nose and her engineering knowledge. A coupling joint in the center tank feed line has failed. The gasket is cracked and degraded. Fuel has been seeping through the coupling and into the aircraft's environmental control ducting for at least 3 hours. The concentration of fuel vapor in the aft lower fuselage is measured at a level that the senior fire officer later describes in his report as significantly elevated, not yet at the explosive threshold, but trending in that direction. If the flight had continued another 2 hours to Lisbon, 2 things would have happened. First, the fuel quantity would have dropped below safe operating minimums over open ocean. Second, the vapor concentration in the lower fuselage could have reached a level where a single electrical arc, a static discharge, a relay click, a short circuit in the aft cargo bay wiring could have caused ignition. The fire officer writes in his report that the diversion decision, based on the flight attendant's initial detection of the fuel odor, was the critical intervention that prevented a potential catastrophic event. The passengers deplane into the Keflavik terminal at 11:42 p.m. local time. They're tired, confused, and anxious. Some are angry about the delay. A few complain loudly about missing connections. They don't know. They don't know that the woman who served them dinner 2 hours ago saved their lives by smelling something wrong and refusing to be silenced. They don't know that the captain told her to serve coffee instead of opinions. They don't know how close they came. Over the next 72 hours, the story emerges. The airline initiates a formal investigation. Maintenance records are pulled. The coupling joint that failed is examined in a laboratory. The defective gasket is traced to a batch from a supplier that has since been flagged for quality issues. Rebecca's former colleagues at Boeing would find this grimly unsurprising. The investigation focuses on 3 areas: the maintenance procedure that failed to catch the defective gasket, the catering of fuel load calculations, and the captain's decision-making during the event. The findings on Captain Nolan Price are damning. The investigation reveals a pattern of behavior that extends far beyond Flight 562. Over the past 3 years, Price has consistently filed flight plans with fuel loads at or near minimum regulatory requirements. He has a documented pattern of declining discretionary fuel, the extra fuel that captains can request beyond the calculated requirement as a safety buffer. On 14 separate occasions, he loaded less fuel than dispatch recommended, substituting his own mental calculations for the computer-generated figures. On Flight 562 specifically, the investigation finds that Price initially loaded 47,200 kilograms, adequate for a normal crossing but with minimal margin for unexpected events. His own mental calculation, which he used to override the dispatch recommendation, underestimated the headwind component by 1.8%. A small error, the kind of error that doesn't matter when everything else goes right, but when combined with a fuel leak that his mental math couldn't detect and his pride wouldn't acknowledge, that small error nearly put 190 people in the ocean. Price's license is suspended immediately pending the full investigation. 3 months later, the suspension becomes a restriction. He's downgraded from wide-body international operations to domestic narrow-body aircraft with mandatory CRM retraining and a minimum 6-month probationary period with check airmen observing every flight. The airline's chief pilot delivers the decision personally. He tells Price that technical skill without judgment is a liability, not an asset. Price accepts the decision without argument. It's the first time anyone at the airline has seen him accept anything without arguing. First Officer Amanda Chen receives a commendation for her actions during the event. The investigation specifically notes her decision to independently verify the fuel system data after receiving information from the cabin crew, and her willingness to assert authority when the captain's judgment was compromised. She's promoted to wide-body first officer within 4 months and is placed on the fast track for captain selection. During her promotion interview, she says something that becomes quoted in the airline's CRM training materials. The most important instrument in the cockpit isn't on the panel. It's the person sitting next to you, and sometimes it's the person standing behind the cockpit door. The maintenance facility where the defective coupling was installed conducts a full review of its procedures. The gasket supplier is audited. A fleet-wide inspection of all 787 center tank coupling joints is ordered. It finds 3 additional aircraft with gaskets from the same defective batch. All are replaced. The airline implements a new policy requiring that any crew member report of unusual odors in the cabin triggers an immediate and mandatory fuel system check, regardless of the captain's assessment. The policy is named the Thorne Protocol. It spreads to 2 other airlines within a year. And Rebecca Thorne, the airline's vice president of safety, calls her personally 3 days after the incident. Not to thank her, though he does that too. To offer her a job, a real job. In-Flight Safety Systems Advisor, a newly created position that bridges the gap between cabin crew and engineering. Her role is to develop training programs that teach flight attendants to recognize technical anomalies that fall outside their normal training. Fuel odors, hydraulic smells, unusual vibrations, the subtle mechanical symptoms that engineers recognize instantly but that cabin crew are never taught to identify. Rebecca accepts. Her first training module focuses on fuel system awareness for cabin crew, what jet fuel smells like, what it means when you smell it, and exactly what to do when a captain tells you to stop talking about it. The module includes a section on crew assertiveness. It opens with a quote, "Serve coffee, not opinions." The quote is attributed to an unnamed captain on an unnamed flight. Everyone who takes the course knows exactly who said it. Rebecca still flies 1 route per month. Not because she has to, her new role is ground-based office and classroom work, but because she wants to. She says she needs to smell the air, needs to walk the cabin, needs to keep her senses sharp. And every time she steps onto a 787, she runs her hand along the fuselage as she enters. A quiet greeting to the aircraft she helped build. The aircraft that almost failed, not because of its engineering, but because the person commanding it confused calculation with judgment and dismissed the one voice that could have helped from the beginning. Because opinions aren't all equal. Some come from ignorance, some come from anxiety, and some come from 6 years inside the machine, hands deep in the systems, understanding every flow and every failure mode at a level that no shortcut can replicate. The dangerous thing isn't having an opinion. The dangerous thing is silencing the one person in the room whose opinion is worth more than everyone else's combined. And at 38,000 feet over the North Atlantic, with 190 lives suspended above black water and the fuel bleeding away beneath their feet, the most valuable thing on that aircraft wasn't the captain's math. It was a flight attendant's nose and the courage to trust it.